Welcome and hello. This is a support video for HEC RAS, and I'm titling this video 2D Flow Time Series Results. So after you've run a 2D flow model and you want to get the discharge or the flow rate time series data across one of your structures, this is the support video to describe how to do that. All right, what I have on the screen here is a completed model with results showing up here in RAS Mapper. The video description includes a couple links to previous videos where I've set this particular model up, specifically HEC RAS Support 7 and HEC RAS Exercise 33. So go ahead and click on those links and check out how I built this model if you're interested. So what I have in this model is a bridge. Water is flowing from the upstream side through the culverts down through the downstream side. If I open up the geometric data editor and then click on SA/2D connection, here is our bridge or the cross section. It's actually modeled as an inline structure. As you can see here, the structure type is weir, gates, culverts. So we have a bridge, and then we have two different groups here for the culverts. There's these two rectangular shaped groups, as well as the second culvert gate group, which are these circular culvert barrels right here. If I open up the culvert button right here, culvert group 1 is called bridge 1, and then I also have row 1. So bridge 1 is the two rectangles. As you can see here, there's B1 and B2, and then culvert group called row 1 are the circular 6-foot diameter barrels, which range from B1 up to B9. All right, so yeah, it was video support 7 that set all that up and ran the model. So to answer the question about how to get the data for the results, specifically the discharge time series data, I'm going to go ahead and close that, close the geometric data editor. What you're seeing on the screen right here is the results. This is the depth as a function of time. So I'll go ahead and click through the animation here of the results. Again, we're looking at water depth. So what happens is the water level increases as the flow increases, and then it decreases later on. The upstream boundary conditions, I'll show you that real quick, is I'll click on this button right here for unsteady flow data. Here's the flow hydrograph. And then here are the values for that upstream flow hydrograph boundary condition. And then here is a plot of that data. So it starts down below 1000 CFS. It peaks at 6000 CFS, and then it comes back down to 1000 CFS over the course of 24 hours. Okay, so to answer the question of how to obtain that discharge time series data through the structure, through this inline structure, I'm going to open up DSS View. So go ahead and download and install DSS View if you haven't already. I'll leave a link to in the description about how to do that as well. It's just another HEC program. And then go ahead and go File, Open. You want to navigate to the DSS file that's storing the results for your particular simulation, and then click Open. And then you want to find the specific paths and get that data. So here's bridge 1, that's the name of the bridge. This is going to have the total flow right here. So let's just go ahead and open that up, and boom, here is our total flow of water passing through that bridge structure during the 24-hour simulation. This is just a plot, but if you wanted the actual data, you can click on the file and then tabulate, and then this gives you the actual numbers right here. So it peaks out at 5883, which is about what we would expect, because remember that peak flow rate at the upstream end of the model was 6000 CFS. So there's a little bit of a upstream storage taking place. If we wanted to identify which of the culvert groups and the weir that the flow was passing through, then we can also get that data here. So here is the weir flow. I'm going to plot these two plots together, and as you can see, there's 0 weir flow. I can get the table data by just clicking on table. There's 0 weir flow, and again, this is the same total that we saw before. And then finally, the breakdown between those two rectangular culvert group, that's group 1, and then the 9 circular culvert groups. We can get that breakdown. Right here is culvert group 1. That is the two box culverts, and then the 9 smaller circular culverts are right here. This sum should be the same as the total. So let's open up the plot here. Okay, so that looks good. Here in yellow, we have the 2 box culverts in larger size, and then in blue right here, this is the 9 circular culvert barrels in that inline structure. So the blue plus the yellow should equal the green. We can again open that up in the tabular format. 408.7 plus 200.3 is 609. So we could continue that all the way down for all 24 records, 25 records. All right, hope that was helpful in identifying the flow rate discharge through a structure when running a 2D simulation in HEC RAS.